So now, when you use a resistor to limit current, there's two important things. The value of the resistor, also the voltage, but it's not the full supply voltage. You can see we got 5 volts right there. It is the voltage across the resistor, and so that will be about 3 volts because we have a red LED right there, so you can see 3 volts. And the reason why is because it takes about 2 volts for the LED to conduct. It builds up that 2 volts, and ultimately it takes away voltage from the series components. That's called drop. So we got 5 volts at the supply, but 2 volts are dropped. So we got 3 volts across the resistor, which sets the current. So now we have a blue LED being protected by a resistor from 5 volts. The current that flows through the circuit is determined by the resistor value and the voltage, but not the full supply voltage right there. We got 5 volts, but only about 2 volts are across the resistor. That's because we're using a blue LED. The red LED, we had 3 volts across the resistor. Blue LED, we only have 2. Blue LEDs are brighter though, so it's probably brighter than the red one was. But in any case, the blue LED drops about 3 volts. Red LED drops about 2 volts. But that's from the supply voltage as far as the resistor or anything else in series is concerned. There's 3 volts less to work with. So we got 2 volts now across the resistor divided by 220 ohms to determine the current flowing through this circuit. Probably 4 times as much current as we need. These are pretty bright even though it's not really showing up on camera. You could probably cut it in fourth by using 4 times the resistance.